So I would like to welcome you to the presentation of connection of Dlubal and Tekla softwares. My name is Aleksandra Kociolek, and I have this pleasure to represent Dlubal company. Okay. My presentation will contain a few parts. The first part will be short introduction about our company, especially for you who don't know us already. Then I will have brief introduction or theoretical background about interface between Dlubal and Tekla. And the last part will be live presentation of both programs. It will be similar that my colleague Arvidas did in a few seconds ago, but I will focus on Dlubal side of this presentation. Okay, so Dlubal Software is German-based company with 2 offices in Germany, in Lipsk and in Tiefenbach. One office in Prague, when most of the development takes place. And also this year we opened one office in Poland, in Katowice. And I have also this pleasure to be in this office and represent this office. Overall, we hired about 180 employees, engineers and programmers. After 25 years of being on the market, we gathered a worldwide customer base, and currently we are used by over 7,000 users. As far as our products, we have 2 main programs, Erstab in version 8 and Erfem in version 5. Erstab is programmed specifically for member-based constructions, and Erfem is more sophisticated one, and it gives us possibility to model and to design every kind of surfaces, plates, walls, solids, and also has such more complicated functions and as for example contact elements. Both of these programs are different, but the interface of them is really similar, so there is no problem for a user to use both of them. Also, both of these programs are basis for modular system that Dlubal Software has. Because of this modular system, we are able to create customized software package, which is special for your needs. For example, for timber design, for example, for steel design. As I said, Erfem is one of the main programs. It uses finite element method for calculations. You can model the structure in this program. You can define loads, load combination. You can do it manually or you can do it automatically. You will run calculations. In result, you will gain the internal forces, deformations, support reactions, and stresses. When you would like to deal with further topics, for example, design or other analysis, you have to use the add-on modules. As you can see at the picture, we have possibility to design steel, concrete, timber constructions. We have powerful tools for the dynamic analysis, where you can perform seismic analysis, you can perform force vibration time history analysis. We have tools for design laminate constructions, steel constructions. We have also package where you can model, you can have equipment and loads and design of lattice tower constructions. You can perform, for example, analysis of geometrical nonlinear calculations with second or third order theory. Also imperfected constructions, when you can, for example, use buckling modes as an imperfection of the construction. So as you can see, we can deal with easy tasks as we are dealing every day experience and everyday work, but also we are able to deal with very specific topics. Here you can see the typical view of our program. At the top you have toolbars. At the left side you have a navigation tree. In the center you can see all the constructions in the workspace. When inputting data into our program, you can help yourself with workflow, let's say from top to bottom, in the part of navigation tree. In this way, you can go point by point, from up to down, and model all the construction. After this, you can use the add-on modules to design our structure. As you can see, this is some kind of guided workflow which makes you easy to work with our program. Everybody likes to brag a little bit, so I will show you a few constructions that we were used to. The first is the Ferrari Theme Park, Abu Dhabi. I think this year it is opened, all opened. It is built on the biggest natural island in United Emirates, and the most important thing is the biggest framework construction in the world, like right now, because it is 117 beams in this construction and 42,000 of connections. So it's really enormous structure. Here we can see Centre Pompidou Metz. It's a branch of Georges Pompidou Center in Paris. The architect, the Japanese architect, Mr. Ban, created this or designed it as head of Chinese head. And the most important for us, I think, is that it's built from timber and glue laminate timber. And as you can see, there is no problem with any kind of curved elements to model in our program. Here we can see the roof in airport in Moscow. Because of large capacity of the airport, there was necessity to build the third terminal, and to connect the terminal with the car park. There was built the roof, and there were also built the footbridge. Here on the picture you can see this roof part, and it was all designed in Erstap. Here you can see Baku Flame Towers in Azerbaijan. This is the structure which contains three buildings, 3 towers. The overall height of it is 190 meters. And here you can see only the top part of it. And as you can see, we are not only used in civil engineer projects, in buildings projects, we were also used for reconstruction design for ship. Aleksandra von Humboldt II is the ship of German Navy. Okay, so let's talk about interface, Tekla and Dlubal interface. I would like to start from some information about our cooperation. Our cooperation is long cooperation, let's say even traditional one, because we cooperate over 15 years right now. We start with X-Steel interface, which after years come into Tekla structure interface. And we start with exchanging data on the file-based process, and we exchange DSTV files. But after both companies introduced COM interface and .NET interface, we were able to use direct data and access to direct data in both programs. And right now, we have bidirectional interface between those two programs. It's important to know that it's working in 32 and 64-bit environment. And as it was said before, we are able to export and import physical model and also analytical model. As you could see, the physical model is the model that you are building in Tekla, but it is not equipped with knowledge about static and mechanical model. So it doesn't have any kind of support, any kind of loading, any kind of releases. But the analytical model gives us opportunity to import all this information from Tekla structures. When importing model from Tekla to Dlubal, as you can see, you can import physical model, but we have to remember that if for example, members are not connected, we will not have this connection in our software, in Dlubal software, so we have to work on it in our program. Also, we can import analytical model, which also, of course, I will show in a second. We have few options there. We can import also load cases from Tekla, and we can import rigid links. I will tell you something more about it in a second. Here you can also see the difference between analytical and physical model on the right part of the slide. When exporting the changed or the new model from Dlubal to Tekla, you can overwrite our existing model. You can also append our model. Its special function is for the purposes of building whole model in Tekla by parts from Dlubal software. And also you can update the model, so you can merge the information from both those models. Here also we have few options of updating. You can update height, you can updating cross sections, thicknesses of the elements, and it's also important to mention that you can export internal forces. And it's also very important to remember that we have to think about continuous member that appeared in our program static one. I will show you also in a second. What kind of scenarios of working with our program we have? We can build our model in Tekla, then send to Dlubal, make all the analysis and design, and after changes, we can send it back to Tekla. Also, we are able to make whole the construction in Dlubal, because as you will see in a second, there is a lot of function in our interface that it's similar to the CAD interface. And after building all the construction in Dlubal, we can send it to the Tekla and then make all the detailing or the drawing work and so on. When you will be making analytical model in Tekla, you will find or notice some solutions for particular problems when making this model. The first thing is rigid links I was saying before. When we have two elements that are connected to each other, but the axes are not lying in the same line or in the same depth, automatically, when making an analytical model in Tekla, there will be a rigid link created. This rigid link will be transferred to rigid coupling in Dlubal software. As I said also before about set of members and about continuous elements, when you are designing or you are preparing analytical model in Tekla, from some reasons, very often, one element will be divided into parts. And in our program to ensure that after sending it back to Tekla, that it will be the one part all the time. There will be created set of members. And this is the option I was talking about before when sending the element, the model to Tekla, that we have to ensure that we have checked this position and check this option. Also, it is possible to send internal forces to Tekla structures. And it is important for that you can continue with detailing and continue designing of, for example, connections in Tekla, because Tekla has also calculators that can do that, and you can check it also in Tekla structures. And also important thing, also important thing, we are able to import and export all kind of cross sections. It is everything written in mapping file, and we can deal with cold form shapes, boxes cross sections, parametrical one, and in this mapping file you can also save the data about any kind of special cross sections that it's not in the our basis in our program. And the same it's about materials. Every kind of material that you will put in the program, which is not in the database in Dlubal and in Tekla, when you will save in this mapping file, you can import and export without any problems. Oops. Something is freezing. Okay. The last information, I would like to encourage you to visit our website. You can find there a lot more information about interfaces, about our program. You can meet us also or follow us of every kind of social network. There you can find some tips and tricks how to work with our program. And of course, I encourage you to write to us or to Ernestas to find more about our programs. Okay, let's go through the live demo. Okay. This is the first window that will occur in the when you're opening the program. The most important thing is, of course, the name of the project. But here is also possibility to classify the loading cases and the combinations according to codes. I will pick the Euro code. I will leave the default annex. Of course, we can see all the coefficients here, and we can change it as we like by copying the annex. Okay. And also, yes? Okay. Okay. And also, I will open right now the model in Tekla. It will be simple model that contains concrete elements, also steel elements. Let's say we got this simple model from maybe architect, and he wants just to ensure himself that the cross section that he picked are okay. So we got such simple model. As you can see, we can with double click see the parameters of the properties of the elements, and also we can go through through analytical models, because also they were prepared, and see that it's prepared the part analytical model and also the whole part analytical model. Okay, let's deal with this one. It's important to know that there is no problem to analyze only few parts from whole model. We don't have to make whole model at once. So if there will be such need, we can also only do simple design on the picked elements. And about the whole model, it's very similar, of course, to the model that we saw before. We can see the properties of this model. This model was created in the axis lines of the elements. There is a lot of possibilities to deal with this problem. We can make it in natural axis, this model, or we can make it in references axis. The first step is to set it here, but also after making this analytical model, we can change it for every element separately. Okay. So we can see here the analytical model. We can see the support. When we double click on the frame element, on the beam element of the frame element, we can see what kind of type of element is this. This is column. Here we can set the support conditions at the end and at the beginning of the element. Also, it was shown that there is possibility to define loads. I will leave it like this, send it to Dlubal, and I would like to show you how to do it well in Dlubal software. Okay, so right now I am going to Dlubal, and I am importing the whole construction. I am importing analytical model, and only I will import rigid links. It will list, okay, I am picking the whole model. It was the first one. It takes a second. There is a lot of data. And here we see the analytical model. Here we see the support conditions. Here we see the concrete elements. Also, we can see the steel elements. With double click, we can edit the element. We can see the releases at the ends of the element. When we go to materials, we can also see what kind of materials were used. We have here concrete, steel, and concrete undefined. We will, in a second, deal with this. And in the comment, it is also important. You can see the name which were used in Tekla structure program. Okay, right now we have to deal a little bit with this model. At first, I want to deal with the beams. I would like them to be at first with defined concrete, not undefined. And the second thing, I would like to have it as a rib, not as a normal beam in the center line. So I will pick by special selection our cross section, beam cross section. It's 300 over 500. Okay, everything will be selected on the yellow, as you can see, and with double click I will edit it. Here also I would like to mention what kind of member types we have in our program. We have beam type. We do not consider column, beam, or other types. We have only beam type, and it's all about the conditions, support condition of the end conditions, sorry, of the element. We have also rib, which I will show in a second. We have truss element which have implemented hinges at the end of the element. We have tension elements which works only with tension forces. Compression, it's analogical with compression forces, and couplings rigid widget. This is the rigid link I was talking before. I go with RIP, and I will make it with integration with, let's say L6. It's okay right now, and right now also I will change the material for concrete C3037. Okay, and you can see it was all changed. Right now it's not blue, it's gray. This is the same concrete as plates has, and also it is as RIP. It is not as beam in the center line. This was the first thing. The second thing, I can add some kind maybe of bracing in our steel construction. I will prepare a new member. I will prepare a new cross section. Here you can see our library of the cross sections. We have here rolled cross section, and there is a lot of databases from codes and also from factories that are preparing or selling the cross section, the steel cross sections. I will cancel it because I will make it parametrically, and I will make the bracing, like say 20 millimeters from steel. Okay, and it will be tension type. Okay, and I will just draw these members into our program, into our model. Okay. You can also easily copy it, for example, like this, with Control button and with left. Oh, sorry, but here I don't have a lot of place for managing with this. Okay, you can just easily copying to another span, for example. Okay. Also, I would like to do some kind of opening in the second slab, second story. I will have to change the placement of the workplace, and I will just pick the rectangle opening. Yes? Okay. Here you can also see, I hope it is seen. Okay, that there is some kind of line, like dot line all over the elements, and this is the set of member setting. When you have like normal element, there will be not this sign. This, when you can see here like this dot line all over next to our elements. It means that there is a set of member. Okay. Right now, I just want to check if everything is okay, if our construction is stable, if we are dealing with analytical model in Tekla structure, and we are preparing it in proper way. There is not a lot of changes we have to do in analytical model or static model in Dlubal software. Everything is prepared to be counted. So I will just make sure that everything is okay. And I will choose the self-weight loading and just to run quick calculations of this load case. It will last a little bit because we have tension elements which are nonlinear elements. So we have like nonlinear analysis here. So if you would like to ask me right now any question, I don't think so. Okay. Do we have any students maybe on the room, or maybe teachers from universities? Yes. Okay. It's good to know. We have really nice offer as for universities, as for students. It's good to know that our version for students is for free and they can use it for thesis and for their work in university. So you are more than welcome to call us and to ask for such version, student version. Okay, it lasts longer than I thought. Okay, we have it.
So you make analysis.
I am trying just forces right now. Okay, I just wanted to check if everything is okay and the construction is stable. We can see here the forces on the the deformation, global deformations of the plates. Also, I can see local deformation in the members. I can see it here, for example. So we can check it. Everything is okay. Let's say it looks reasonable, and we can deal with other load cases. Before I picked that I would like to classify our load cases according to Eurocode. Right now I can go to the table when I can define other loading. Here I have self-weight. Then I can, for example, put imposed load and let's say snow load. Here you can see that the action category was chosen automatically, and going through. Okay, there is something wrong. Sorry, I will check general data. Okay, I didn't choose to create the automatic combinations. So I am doing right now, and the program will have this ability to make the combinations by its own. Okay, so I have action categories. I have combinations to analyze. Let's say we will pick only serviceability. Ultimate limit states. We can of course check or choose from which equation we will be making combinations. After this, we have action combinations, load combinations, and result combinations, which is envelope. Okay, but still you can see it's really fast process. Right now I have every combination that I need for ultimate limit state. And right now I will put some loading because we don't have it right now. We have self-weight. We will put imposed loads. It will be surface load. I am picking the new surface load. I will give the magnitude. It's minus, let's say, 1.5. And I will pick only the surfaces on which should be applied. Then I will go to snow load. And I will use the generator for this. We have a lot of generators in our programs. We have generators that helps you model the structures, but also the generators that helps you to load the structure. And I will use a generator for snow load, for flat roof, and you can see here also that it is according to Eurocode. I will just change the annex. I will stay with international one. And you can see here that there is every setting that we have deal also by hand when we are counting the snow load. There are settings directly from Eurocode.
Well, just one question. I think it's important then for Lithuania and for Latvia. What about codes which are in Russian?
In Russian?
Yes.
Okay, I was expecting like a Lithuanian one. Okay, we get the certificate for Russian right now.
Okay.
A few weeks ago, so you can use it also in Russia, and I am quite sure that also Lithuanian and Russian annexes will be implemented in a few months. So.
Thank you. Nice to know.
Okay, so I will pick the roof geometry. Here I will just pick the geometry of the member construction roof. Okay. Here we have also other option, for example, to remove influence from some members. We will leave it like this. This is the control table when we can see what is the area of our load and the value of our load. And you can see here loading at the top of the roof. You can of course edit it and see how it is reduced or how it is on the every beam. I will leave it like this, and also I will make the same load for these two slabs. The magnitude I think was 80. Okay, and I will put it here and here. Right now we have prepared, let's say, loads and combinations, and I can deal with design process. At first I will pick the steel EC3, so I will design steel members. Here, as you can see, there is option to design member or set of members. Everything, it's about you, it's on your side, how you want to deal with this problem. It's also all about backlink lengths and every kind of support and connections which will be taken to account when designing. I will pick right now a few elements here, maybe. It's okay. Also here you have national annex. You can of course edit and you can change and edit all the values you have here. I will pick some combinations for design. I will go briefly through the details and settings. Here we can see the material. We can of course check it. We can change it from this level. There is no problem. We can, as you can see, import or export it. So it's all the time, everything is it's for you to edit. Then we have cross sections. Here you can see like the one cross section is in black. It means that this one will be designed, and the other are in gray. This means that they are not like available for now for this designing module. Okay, and here of course we can also optimize it if we would like to. Okay, then we have intermediate lateral restraints. This is especially used in set of members when you can deal with supports from other members. Here we have really simple elements, simple beams, so there is no other elements which can change our backlink length. Then effective length, we can use this kind of, let's say, shortcut. We can, when we don't remember what kind of backlink length there is, we can see it. But the most important is we have also the module, which now it's enabled, that it's able to count our backlink length, and we can import it into our design module. It is important because sometimes we are not able to classify, or we are not able to pick the correct backlink length. So it's a really good tool for make our work also easier. Let's say it's done, and we go through parameters. Also, here are the settings that helps us with rotation problem. We don't have to analyze the member from the ideal, let's say, structure or ideal model. We can have here, for example, the not model in our program, but still important, for example, some coating on some roof over our constructions, which give us opportunity to minimize the rotation of our element. I will leave it like there is nothing, and we can go through also into details. We have details for ultimate limit states, about cross-section classification, stability, when we can, for example, pick the method of the analysis. We can do it by general method or in equivalent member method. Everything is, of course, in Eurocode. Here also we have special settings for special cases in designing, for example, rotation, for example, of course, torsion, and the maximum coefficient of torsion or other forces which are in our elements. In serviceability, we can also pick reference system, reference model we will take into account when dealing with deformations. We have also fire resistance settings and other settings. In case of optimization of cross section, we can also pick the maximum design ratio we would like to have in this cross section. Okay, also we will run the calculations. Right now it will have to also calculate the... it's also time for questions, of course, but here it will have to count the forces, and then it will be a design process. Of course, I am using default settings right now. The mesh is of finite element is 50 centimeters of the plate. We can of course deal with it case by case. You can change the mesh of every element, of every line, every point. So it's also up to you. Also, the increment steps and iterations are default. This is also up to you what kind of settings you would like to have.
Maybe we will use this pause for a question. You mentioned, you asked who is from universities. I
Yes.
know that there are and Vilnius and Kaunas and Riga technical university representatives. So maybe you can share Dlubal, let's say, practice and experience working together with academical institutions, universities, and so on. Shortly, just how many maybe?
We are of course cooperating with Austrian and German universities, and of course there is a bunch of our, not bunch, a lot of our engineers that also cooperating with these universities. Also, we have cooperation with Prague University, especially in glass design. So you are more welcome also to help us, of course, and to cooperate with us when we are talking about some kind of let's say checking models and so on. So you are welcome. This is all. Yes.
So, as understood, you are speaking not only about just to give the university software and make some maybe training. It means that you are working together in some cases.
Yes, also, okay. Of course. And about training, we are also eager to make every kind of presentation for you. It could be for students, which is less complicated, but also theoretical one, how we are dealing with the problems in our program for teachers and for doctors from university. So if you will have such suggest or such request, please contact Ernestus, and I think we will think something through. Okay, we have counted, let's say, 4 beams from our model. Here we can see right now the results. There is a lot of it. I hope you can see it from the back row. We can separate, see the result by load cases. You can see here 2 load cases and maximum design ratio that appears in our elements. The same you can see by cross sections or by members. The most important thing is that you can see here condition that was checked from Eurocode, and also here in the bottom you can see every value that was used for this condition. This gives you opportunity to check also what happened in the program. Here you have also comment and signatures of equations, of tables that we are also using, of course, from Eurocode. So every data that it's in the program, you can check also to Eurocode, with Eurocode. You have ability to see every data that it's taken to calculations. The last thing is list, part of list. Of course, we don't have a lot of this, but it also can help you what kind of, how big is your construction, what is the total weight of your construction or elements you take into account. When we see the graphics, you can see the design ratio here of the element. I hope it is seen. I can pick only these elements and show you only this one. Okay, here you can see the design ratio. It's a little bit strange here, so we should look at it. Why it's like this? Of course, it's only for ultimate limit states, so there is no deformation checked. But still, this view you can also see in traditional way. Okay. In traditional way, and give it to the, for example, printout report later. Let's look also to a concrete. Oh, sorry. Okay, I will disable this, and maybe I will try to make some really brief reinforcement design on the last slab. I go through add-on modules, concrete surfaces. And you can see it's very similar. First, I have general data. I will pick some combinations to be designed. Then I go with materials. Also, I can check it. Also, I can change it from this level. Surfaces, I can see which surface has what kind of thicknesses, and also I can edit it here. And I have to pick the reinforcement. At first, maybe I will pick only one surface to be designed, only this one. And here we will be dealing with the settings. These are reinforcement ratio. Everything is, of course, for you to edit. Here we have reinforcement layout. We can put a cover or set a cover according also to Eurocode, but by checking or setting all the settings we have here, for example, exposure class, the cover will be automatically recounted. Here you can see that it's changing. Then we have longitudinal reinforcement. We can also set it, for example, 12 millimeters bottom and top in both directions. There will be the same reinforcement I am adding. Also, there are meshes from a lot of companies implemented in the program. And also I have here the options what to do with the reinforcement when checking shear resistance. Let's say automatically increased. Here are the settings from code, European code, and later we can also pick the design method. Okay, I will also run a calculation. Here we have the warning that something is not good enough with the cover, and you can see here was 3.5, right now it's 4 centimeters. So the program is also checking every setting that we gave. Okay, calculations, it was fast because the internal forces were counted before, and you can see the required reinforcement, basic reinforcement, and additional one. Here we have some point which is not for design. It's not that we are not able to design it, but it means that here over the column we have to have more reinforcement and to check the punching. This is why we have here on red that this is not designable. I will go to graphics. I will pick only this, only this plate. Also visibility mode. Okay. And we can see what happens. Here we have beams, so we have also here more stresses. Here are the columns, so we can see the peaks of the also stresses, also reinforcement. We can also see the reinforcement in both direction, bottom and top. Yes. So, and we can see the map of it. Right now we are working on more maybe useful function to put reinforcement not all over the whole plate, but with the how to say it, to divide it into some kind of I don't know, strips, let's say, to make it more realistic. Okay. Right now, let's say we design the construction. Okay, well, I have upside down, unfortunately. Okay. We designed the construction, we made some changes, and I would like to send it to the Tekla. So, I will just pick the function to export it. I will maybe overwrite the existing model to make it easier. I am remembering about this set of members that I want to be the continuous member in Tekla model. And also I will send the internal forces of, to the model. Okay. I will close it. And here we have our new model. Here you can see the opening. Here you can see the bracing. And when I double click the element and you see the user defined attributes here, oh, something goes wrong. Okay. I don't know why internal forces didn't go there. There should be information about internal forces, but right now I am not sure if I send it. Okay, so we have all the information that it were changed. We can see also that the beams are not in the center line, but it's with the offset of the rib. So you can see that in this easy way you can change the model very, very quickly. Okay, thank you. This is all for my side. If you, yes?
There was one question.
I maybe repeat this question for Nessus, but can you tell more information about libraries, about element libraries, about what manages these libraries, what creates these libraries? Maybe you... Libraries.
Okay, of course.
May you answer in this question? May you say about your country?
Okay, of course. As At first, I will tell something about libraries of our cross-section or material libraries. And after this, I will show you what it looks like when we are importing and exporting data, so the mapping file, where we can deal with special cases. Okay, when we are picking the cross-section library, here you can see the implemented cross-sections, and they are divided by manufacturer and also by Eurocode. It can be used as, you can see it's a lot of them. So it's also Japanese codes or Japanese manufacturer, yes. So it's all implemented, and this library, it's all in all the time like expanding, okay? When we are dealing with material database, here you can see also the materials from different codes implemented, and also this red one are invalid ones. So we have the new material parameters or materials implemented, but also you can all the time use ones that they are not used in actual designs. So all the time you can check, for example, constructions which were designed for this kind of parameters. And when we are dealing with, I will show it here, when we are dealing with importing or exporting the data, you can see here the formats we are able to import or export. Here are direct import and this tecla structures. So with detail settings, here you can see the special mapping file. Right now it's empty because everything here, what we were importing and exporting, was typical for both of programs, so there was no problems. But if you have some cross-section that you defined by your own, or materials that you also defined on your own, you can save this file, or you can save this information in this file, and it will give you the opportunity to import and export in both directions with the program. Is it okay?
Some question about managing this libraries.
Managing with the libraries, I don't know. The libraries, like we are taking the materials and the all parametric from the companies or from the codes, of course. And in our company, there are people who are managing this and write it in and save in our database.
So where is the source?
The source are from codes and from a lot of, for example, I don't know how to call it, some kind of, I don't know if you have it in here, in Poland, for example, we have code, but we have also companies that make some kind of research of the material, and we have approbated like materials, so we are also taking it from them. Okay. Any other questions? Okay.
Maybe shortly about reports.
Short about reports, of course, we can do it also. I will create the report, printout report. I will create all printout report, and then we will erase a few things from it to make it let's say, short. Sorry, it's in Polish. I will change it in a second. Of course, there is 12 languages of reports, and this is not a problem to change it. No, to Lithuanian not. We have English, German, French, Italian, Spanish, Russian, Czech, Polish, Hungarian, Slovak, Portuguese, and the Dutch. So let's say we will. There is no problem to make a local language. We can save this translation and translate by own. So if you want to translate your printout report, you are able to do it. Everything what is in this report is editable. Okay, so here we have whole printout report. And here on the left you have navigation tree when you can deal with all the data. Of course, you can set up a page and change all the settings here about margins, about fonts, and so on. Also, you can change the header. You can put your own logo there of your company. There is no problem. Here we have Dlubal software in Czech Republic because this is the license from them. So, but you, of course, when you will have the program, there will be not Dlubal software but your name, name of your company. Also, we can deal with the first page. Let's say, I don't know, Tekla building. Yes, okay. So you can deal also with the first page, with the also drawings. And about the content, as you can see, there is a lot of things that not necessary we need in our reports. For example, notes, we can delete it. Lines, also we can delete. Materials, I think it's important, but as you can see, just by going through this navigation tree, you can pick the topics you want to see. And here we have general data about our program, and here we have also data about design. So here is still EC3. You have also here general data, materials, all the parameters, and all the conditions that we were counting or we were checking in a program. The same is for concrete. Here is general data. Did we pick? What are the settings? So the most important for you is that everything what is here it is editable for you, and it could be done as you would like. This kind of design, this kind of report, you can save as a template and use it in another projects. So you do not have to deal with this every time you make a project, every time you make a model. It could be saved as a template.
What about graphical?
Of course, also we can put here graphics because it's not default setting. I will save it like this. And for example, I will show you from here. I will pick, for example, some part of the graphic. I will make a visibility mode. And for example, I would like to see internal forces for this. And let's say I need such a drawing. I just print it into our printout report. And for example, I can pick the must print. I don't have to make every drawing alone. I can, for example, pick the results that I want to see in my printout report. With these settings, I can go to the printout report, and you will see these drawings here where it should be. So under the result of load cases. Of course, I didn't work on it. It should be a little bit different. It should be not like this. I did it. I did not put any special settings, but you can see all the drawings we wanted we wanted to see. Also important thing, when we change something in our model, here in printout report will be automatically also changed. Okay. So I think this is the end.